Hello everyone, welcome back to my channel, and today we're going to solve Leetcode problem number 509, which is going to be Fibonacci number. So basically we need to write here the nth Fibonacci number, right? So first of all, let's demystify this, what the Fibonacci number actually is. Right, so Fibonacci number is actually formed by adding two preceding numbers. So what does it mean? Basically we have for example, if I'm going to take this number which is going to be present at 0th index, or if I'm going to take this number which is present at first index, if I'm going to add them, so basically we get a number which is going to be the sum of these two numbers, right? Similarly, if I'm going to take these two numbers, 1 or 1, or if I'm going to add them, so you're going to get the next number which is going to be the sum of these two preceding numbers, right? Similarly, if I'm going to take these two numbers and then again if I'm going to add them, so you're going to get the next number which is going to be the sum of these two numbers. Similarly, you're going to add them these two numbers, you're going to get the third number, right? And so on. So this is what the Fibonacci number is. So can I say, like, if you wanted to find the Fibonacci number of 2, right? So if I'm going to find Fibonacci of 2, so can I write like Fibonacci of 2 is actually equals to Fibonacci of 1 plus Fibonacci of 0. Should I write like this? Yeah, right. And also if I wanted to find Fibonacci of nth number, so I should have to write like Fibonacci of n minus 1th number plus you're gonna have to add Fibonacci of n minus 2th number. So like this way you're gonna find the Fibonacci number. So in this problem, or in order to solve this question, I'm going to use a recursive approach. So instead of using recursive approach, you can also use an iterative approach whose time complexity is gonna be equals to big O of n, right? So right now in this question I'm gonna using a recursive approach to solve this question. Okay, so using a recursive approach, first of all we need to understand what the recursion tree is, right? What the recursion tree is, so that we're gonna understand the recursion process gonna be there. Okay, so for example, if I'm gonna taking an example of to finding a Fibonacci number of 5. So if I wanted to find Fibonacci 5, so I think we should have to write like Fibonacci of 4 plus Fibonacci of 3, right? So if we are going to finding the Fibonacci of 5, so it should be right like Fibonacci of 4 plus Fibonacci of 3, right? So let's break down this Fibonacci of 4 and Fibonacci of 3 further so that we're going to understand it. So I'm going to breaking this. Fibonacci of 4 is going to be formed by adding Fibonacci of 3 or Fibonacci of 2, right? So I'm going to write like here Fibonacci of 4 is going to be formed by Fibonacci of 3 plus Fibonacci of 2, right? So this is how it's going to be formed. And now let's break this further. I'm going to break this. Fibonacci of 3 is going to be breaking down into Fibonacci of 2 plus Fibonacci of 1. So I'm going to write over here Fibonacci of 3 is going to be like this: Fibonacci of 2 plus Fibonacci of 1. Right, so Fibonacci of 2 or Fibonacci of 1. And now this Fibonacci of 2 is going to be further breaking down into two parts, which is going to be Fibonacci of 1 or Fibonacci of 0, right? So I'm going to write over here Fibonacci of 1, Fibonacci of 1 and Fibonacci of 0, right? And also we need to just break down this also. So I'm going to breaking this Fibonacci of 2 is further break down into Fibonacci of 1 or 0. So I'm going to write over here Fibonacci of 1, and here I'm going to write Fibonacci of 0, right? And also we need to break down this Fibonacci of 3 as well. So I'm going to do it over here. Fibonacci of 3 is going to be further break down into Fibonacci of 2 or Fibonacci of 1. So I'm going to write over here Fibonacci of 2 and Fibonacci of 1. right? And again, this Fibonacci of 2 is going to be break down further. So I'm going to break this Fibonacci of 1 or Fibonacci of 0. So let's write over here Fibonacci of 1 or Fibonacci of 0, right? So this is how our recursion tree gonna be looks like, right? It's gonna be interesting, right? So now let's solve this. I'm gonna take some another color. Yeah. So Fibonacci of 0 is actually 0. Fibonacci of 1 is 1. So if we're gonna add them, these two number, so you're gonna get Fibonacci of 2, which is going to be 1. Fibonacci of 1 is 1. And I'm gonna add them, so you're gonna get Fibonacci of 3, which is going to be 2. And then again, Fibonacci of 1 is 1, Fibonacci of 0 is 0. You're going to add them, you're going to get 1, and then you're going to add this 2 or 1. So Fibonacci of 4 is basically equals to 3, right? So I'm going to write over here 3. And then Fibonacci of 1 is 1, Fibonacci 0 is 0. You're going to add them, you're going to get a 1. Then Fibonacci of 1 is actually 1, so you're going to add them, and basically you're going to get the Fibonacci of 3 is equals to 2. And then you need to add these two numbers, so you're going to get basically 5, right? So Fibonacci of 5 is actually equals to 5. And now let's check over here. So yes, Fibonacci of 5 is actually 5. So this is how our recursion gonna be works. Okay, so because we are doing recursion, so we know that if you're doing a recursion, so you need a base case, right? If we didn't have a base case, so our recursion gonna be move, or it's gonna be make a infinite loop, right? So to reduce this, so we're using a base case. So base case is very simple. This is gonna be our base case, right? Because at 0th index, our Fibonacci number is also gonna be the 0, and at first index, or if our n is equals to 1, so our Fibonacci number is also gonna be 1. Right, so this is gonna be our base cases. I'm gonna take this our base cases for our recursion. Okay, so now let's move to the coding part. So yeah, so because we are doing recursion, so first of all we need to define the base case. So I'm gonna write over here if n equals to 0. So if our n is equals to 0, or in case if our n is equals to 1, so we need to write n. Why? Because Fibonacci of 0 is actually equals to 0, or Fibonacci of 1 is actually equals to 1, right? So in these two cases, we need to just simply write that number itself. So I'm going to write here n, right? And now let's do the recursion. So for that, we need to call this function. So return, I'm going to write here self. So why I'm writing a self? Because we are doing this question inside a class. If you're going to see over here, it is inside class. So that's why I'm going to write over here self. So self dot, I'm going to call them fib of n minus 1 plus, you need to again call this self dot fib. Okay, it's gonna be fib of n minus 2, right? And that's all. And let's run this. So basically we need to write very less line of code if you're going to do the recursion. And also the time complexity of this algorithm is going to be bigger of 2 to the bigger of 2 raised to the power n. And also we are doing recursion in order to solve this question. So I think it's pretty good. Yeah, it's pretty good to be like this. And yeah, here we done this question, and that's all for today.